Continuous probabilities are for when we can't count all the variables, such as temperature or precise times. The uniform distribution means that an event is just as likely to happen at any point. So, in this scenario, BC Hydro says they are conducting maintenance and have turned off the power. Electricity will turn back on sometime between 2 p.m. and 4 p.m. with a uniform distribution of probability. What is the probability of power being turned on between 3:30 and 4 p.m.? So uniform distributions are represented by the height of the rectangle and the length of the rectangle. So first we need to determine the height. To do that, we're going to use our formula. 1 over b minus a, which would be 1 over 4 p.m. minus 2 p.m., which is 1 over 120 minutes, 70 hours, which equals 0.0083. Now we can determine the length. Our length is between 3:30 and 4. So b minus a, 4 minus 3:30 equals 30 minutes. And if we were to multiply these together, our height by our length, we would have 30 times 0.0083 or 0.249. Now there is a rounding error here, so that is equal to 0.25. So there's a 25% chance of the power being turned on between 3:30 and 4, which makes sense. Half an hour is only a quarter of 2 hours. So what is the mean and standard deviation of this distribution? The mean follows the formula mean equals a plus b divided by 2. So 2 p.m. plus 4 p.m. divided by 2, and that would equal 3 p.m. When we have a look at our standard deviation, we can use the formula square root of b minus a squared divided by 12. So we have 4 p.m. minus 2 p.m. square divided by 12. If we convert these to minutes past noon, in order to complete this, 240 minutes minus 120 minutes as squared divided by 12, and we would get 34.64 minutes as our standard deviation.